13.7 billion years ago, from a minuscule hot dot came the universe. An unbelievable amount of energy expanded, growing to the size of a galaxy. Energy equals matter times the speed of light squared. This is how we get E equals mc squared. When temperatures cooled, matter stopped being produced, and hydrogen and helium increased the temperature to 3,000 Kelvin, only 3 years after the Big Bang. Yesterday, our galaxy was smaller, had more pressure, and was hotter than today.
Tiny fluctuations in the density of the early universe are amplified into a network of interconnected filaments. Along these filaments, condensing gas clouds give birth to new stars and merge into whirling galaxies. Galaxies congregate into clusters, colliding, merging, and forming new galaxies in a fiery cosmic dance.
The evidence we have for this shows that stars expanded from one point and are moving away from us, proved in redshift surveys. It is assumed that at one point the universe had no size at all. Particles have never been found that are older than 13 billion years. Normal galaxies are large bodies that contain hundreds of billions of stars and enough material to create billions of more stars. Normal galaxies were first separated into one of 4 subgroups by Edwin Hubble. These 4 subgroups are spiral galaxies, barred spiral galaxies, elliptical galaxies, and irregular galaxies. The approximate percentages of the types of galaxies within 30 million light-years from the Milky Way galaxy are as follows. 54% are irregular, 34% are either spiral or barred spiral, and 13% are elliptical. Active galaxies emit a great deal more of energy than they should. There are 4 classifications of active galaxies, but the type we observe may depend more upon our viewing angle than structural differences. For instance, there are Cipher galaxies, radio galaxies, quasars, and blazars. All of the galaxies have special characteristics that help them be divided into even more additional groups based on their halos, their nucleus, what kind of stars they have, and their age. The Milky Way galaxy points to being a barred spiral galaxy. Galactic groups typically consist of 30 to 50 different galaxies. Groups can be found everywhere. Spirals contain new stars in their arms. The Hubble Space Telescope has proved this by measuring the color of the light from spirals. If the galactic group has a blue color, it means they have new stars. The distribution of galaxies is made up of large filamentary structures with massive concentrations. This is very much like the early universe. Hubble's law states that the velocity of recession v is directly proportional to the galactic distance d. This equation has formed the basis of the Big Bang theory and the origin of the universe. The redshift survey of the galaxies is a survey of the section of the sky to measure the redshift of astronomical objects. The redshift can be used to calculate the distance of an object from Earth. The measurement of a galaxy's redshift gives you an estimate of that galaxy's distance. We use redshift as a measure of the radial coordinate in a spherical coordinate system centered on the Milky Way. When you combine redshift survey and angular position data, a redshift survey maps a 3D distribution of matter within a field of the sky. The first redshift survey was the CFA redshift survey and was started in 1977 by Mark Davis, John Hookra, Dave Latham, and John Tonry. The data for this survey was completely collected in 1982. The most recent and notable redshift surveys are the 2DF survey, the Sloan Digital Sky survey, the Deep 2